And welcome back, and it's the Further Maths 5 a day for the 17th of Feb, and let's have a look at the first question. Okay, so we have a factorise fully. The word fully often implies that you need to do at least a couple of steps. So let's have a look at what we've got here. So we've got some x's, some y's, some z's, and some numbers. Now if I zoom in a bit, it's going to make this a little bit easier. So you can see all these numbers, 30, 24 and 12, all divide by 6. So I can definitely take a 6 to the outside. Then look for the lowest common multiple of x, so x squared and x cubed is going to give me x. Lowest common multiple of y is going to give me y cubed. And lowest common multiple of z, well, it's going to just be z, isn't it? And then let's see what we multiply by in order to get back to the thing I've started with. In other words, what do I multiply 6x y cubed z by to get 30x y to the 5z? Well, it's going to be 5y squared. And let's continue that for the next one. So 24x squared y cubed z squared, or 24 times 4 is 6, x squared, I need another x. Y cubed is already y cubed, and z means I need another z to make it z squared. And then similar for the last one, I'm going to multiply by 2 to give me 12, x squared to get me up to x cubed, y cubed is already y cubed, and z is already z. And that is the answer to my first question. Nice opening question today. Next question. The first 5 terms of a quadratic sequence. So it's made it much easier for me by telling me what sequence it is. I'm going to do my usual thing of let's work out the second difference, because I know it's quadratic, so it will be a second difference. So it's going to be minus 6, be careful, minus 8, minus 10, and minus 12. Which means the difference of the differences is going to be minus 2. My differences are growing up by 2 each time. So therefore my A term is minus 2 divided by 2, which is going to be minus 1. I haven't seen a minus in a while, so actually good question. Now, as I do, a bit different to how some people teach it, is I write my sequence again, so 36, 30, 22, 12 and 0. And then I do minus n squared, so minus 1, minus 4, minus 9, minus 16, and minus 25. 36 minus minus 1 is actually 37. 30 minus minus 4 is 34. 22 minus minus 9 is 31. I'm hoping these are all going to go down by 3. 12 minus minus 16 is going to give me 28. And 0 minus minus 25 is 25, which does indeed all go down by 3, which means my nth term for this sequence here is going to be, well, it's minus 3n plus 40 to get to the first term, which means I've got my quadratic part, I've got my linear part, put it all together, and it means my nth term is minus n squared minus 3n plus 40. Next question. A curve has equation y equals x plus 2, x minus 3. The gradient of the curve at the point P is this. Work out the coordinates of the point P. Okay, nice question. So the first thing I'm going to do is I'm going to expand the brackets, because I can't do product rule yet. You'll meet that later. So if I expand the brackets, well, 2 minus 3 is minus 1, and 2 times minus 3 is minus 6. Then I'm going to differentiate that, so dy dx. And that's going to give me 2x minus 1. And then it tells me the gradient at the point I care about is minus 4. So in other words, what is the x value that gives me minus 4? Well, add 1 to both sides gives me minus 3, divide by 2, which means x equals minus 3 over 2. But it wants the coordinates, not just the x value. So therefore I need to go to the original function. I'm going to use this one here because it's slightly easier to work out the y value. So therefore y at minus 3 over 2 is going to be minus 3 over 2 plus 2, which is a half, and minus 3 over 2 minus another 3, which is minus 6, which is minus 9 over 2, which is going to give me minus 9 over 4, which means the coordinates of the point P, which gives me a gradient of minus 4, is going to be minus 3 over 2 minus 9 over 4. And that is question done. Next question. Okay, so you hear me say this every now and then if you watch a few of my videos. This is a standard textbook question. You either know how to do this or you don't. And it is a skill you definitely want to make sure you learn. Because I have a plus or a minus on the bottom, I'm going to write the same thing, but I'm going to change the plus to a minus or the minus to a plus. Then I'm going to write exactly the same thing on the top. Now, of course, the reason I can do that is because this divided by this is 1, so I'm just basically multiplying by 1. Now, let's do the numerator first. 7 times 3 is 21. 7 times minus 6 is minus 7 root 6. Root 6 times 3 is plus 3 root 6. And root 6 times root 6 is minus 6. And then I'm going to divide all that by, well, I know it's difference of 2 squares, so I just need to do 3 times 3, which is 9, minus root 6 times 6, which is 6. I don't need to do the bits in the middle because I know they're going to cancel out. Then let's resolve the numerator. So 21 minus 6 is going to give me 15. And minus 7 root 6's plus 3 root 6's is minus 4 root 6. And all of that is divided by 3. Now I could actually just leave it like that. I could also write it as 15 over 3, which is 5, minus 4/5 root 6. Sorry, not 4/5, 4/3 root 6. But to be honest, it's not a lot neater. I'd probably prefer this as an answer if I was choosing one, but they're both acceptable. They both are fine. Right, next and final question today. Show that. So when I show that question, I need to clearly start on the left-hand side, do some maths and make it look like the right-hand side. Do not write the left-hand side and the right-hand side down together. So let's start here. So if I expand this, that's going to give me sine squared theta plus 2 sine theta cos theta plus cos squared theta. And then if I expand this one as well, I'm adding, so it's going to be plus sine squared theta plus cos squared theta minus 2 sine theta cos theta. Now, my 2 sine theta cos theta cancels out, which just leaves me, definitely write this step in between, 2 lots of sine squared theta. Let's write that slightly neater. 2 lots of sine squared theta plus cos squared theta, which is equal to 2 times 1, which is equal to 2, which is equal to the right-hand side. So therefore, I have proven it to be true. And what I might do, just to be super safe in an exam, is write down that sine squared theta plus cos squared theta is equivalent to 1. Just means I'm showing exactly what I'm doing, making it super clear. And that's today's final question done. Okay. I've got to be careful saying nice mix of questions, but good mix of questions today. We haven't seen some of these questions before. Definitely get you thinking, definitely worth going through, and definitely worth practicing in later. As ever, do like, subscribe, leave a comment down below, and I'll see you for the next one. Thanks all.